Hello. So for today, we're going to talk about charge. So this unit, we're doing electrostatics. So electrostatics has to do with electricity. So when we're talking about electricity, what we're really talking about is charged particles moving around. So we're going to talk about where this charge comes from, what we mean by when we use the word charge, and things like that. So we have a really big number this week that'll get explained later. So this 1.6 times 10 to the negative 19 coulombs, this is going to be a really big deal for us. Coulombs, we'll get into it later, is the unit for electric charge. So if I wanted to say how much charge does that have, you can give me an answer of in coulombs. So So when we have things that are charged objects, there's two types of interactions. There's attraction, the two charged objects can pull together. There's repulsion, the two charged objects can push apart. And then there's two types of charge. It's positive and negative. So there's four interactions these charges can have. So opposite charges, one positive and one negative, will pull together, will attract. Opposites attract. So there's similar charges repel. So anything that has the same charge will push apart, whether that's negative and negative or positive and positive. And now we're going to get into what happens when something that's charged goes by something that's neutral. So anything that has a charge attracts something that doesn't have a charge. That's pretty weird. That's a little counterintuitive. So if one thing has a charge and one thing doesn't, they still attract. We're going to talk why. It has to do with a thing called polarization. So uncharged and uncharged, or neutral and neutral, don't interact. So charges are not created nor destroyed. It's separated into electrons and protons. And we talked about this last time, but only the electrons move. If you remember the atom, the protons and neutrons were in the middle, and then the electrons were flying around the outside. Those can get traded between atoms, but the protons and neutrons, the nucleus stays. So quantization of charge. So what this means is if I tell you something has like a +1 charge, that's one way we could talk about charge, or we can actually talk about how much charge it has. This is going to be measured in coulombs. So, for example, to tell how much money you have, you count by pennies. To tell how much charge you have, you count by how many electrons. So, so an electron is the smallest amount we use to count. So one electron is 1.6 times 10 to the negative 19th coulombs. So coulombs, here's our unit of charge. As you can tell, one electron is really small, so the charge is really, really small. One proton is 1.6 times 10 to the negative 19th coulomb, but positive. So it's a little interesting. A proton and an electron, sometimes we use +1, -1. That shows they're the same charge but opposite. But if you wanted to know the actual amount, it's this amount in coulombs. So one neutron has no charge. All right. So here, if you want to find the total charge, you multiply 1.6 times 10 to the negative 19th by the number of electrons. So let's say I had a bin, and this bin had 5 electrons in here. All right, how much charge does this bin have? The answer would be one electron has 1.6 times 10 to the negative 19th coulombs. You multiply it by 5, you get 8 times 10 to the negative 19th coulombs. So that's how much charge would be in the box. You have 5 electrons. Each electron is this amount, and that's what you would get. You'll notice here that we're just talking about magnitude. So magnitude, you don't really need to worry about positive or negative. Okay. You can also use the E button on your calculator. We've talked about this rather than times 10 to the negative. All right. So that's if you're given the number of electrons and they ask you the charge. Now, if you need to find the number of electrons and they give you the total charge, you would divide. You take the total charge, 3.2 times 10 to the negative 19th, and you divide the charge of 1 electron. So the total charge divided by the charge of 1 electron will give you the number of electrons. So you'll see the math down here too, 3.2 times 10 to the negative 19th divided by 1.6 e to the negative 19th. So that's our math here. That's where that number comes from. You take that number is the charge for 1 electron. And if you're told the number of electrons, you can find the total charge. Or if you're given the total charge, you can find the number of electrons. So now we're going to get into how objects are charged. So objects are charged by giving it electrons or taking it away. Electrons are the ones moving. So when we're talking with materials, some materials, electrons can move through easily. We call these conductors. That would be like a metal wire or something like that. The reason why wires are metal is because electrons move through them very easily. And electrons moving is what we call electricity. So if I have one end of a wire and the other end, and I shoot electrons from one end to the other, that's really what we mean by electricity. So an electric zap is really just shooting electrons. Or think of a lightning bolt. All a lightning bolt is discharging electrons from the clouds to the ground. And we call it electricity. So what we need to know from this slide is conductors versus insulators. Conductors, electrons move easily. Insulators, electrons cannot move easily. So it's not that electrons can't move, it's that it's harder for them to move through. So both of them, there's no proton movement. So metals are good conductors, and then things like wood, paper, plastic, rubber are good insulators. So usually you'll have a metal wire with a plastic casing. So that way the metal can move easily through the wire, but can't move outside the plastic casing. So conductors versus insulators. That's this slide. All right. Now, the next idea with charge is how do you make an object charged? I have this coffee cup. It's neutral. How do I get this to be charged? There's a few different ways. Conduction versus induction. So charging a conductor, you charge by contact. Touch an object with a charged object. So if we look here, we have a charged object, we touch it to another object, and we send the electrons there. All right, let me go back for a second. So the big thing here is conduction is charging by contact. If I take this coffee cup and I have a negative object, if I rub them together, that'll charge the coffee cup because the electrons will go from the charged object to the coffee cup. The other thing is charging by induction. So conduction, induction. So induction is charging without touching. So if you look at here, we have A and B are neutral, no charge. Here, we bring a negative balloon near it. What happens in induction is the negative electrons move away from here. So these negatives and the negative electrons in the sphere want to move away from each other. They have repulsion. So all the electrons move to the right. That leaves the right side positive or the right side negative and the left side positive. So I don't even need to touch this balloon here for these electrons to feel its force. So now if I was to separate those two things, the left sphere would have positive and the right would have negative. And if I look at the last one, now I have a positive and a negative object, even though my balloon never touched. So ways to charge: conduction, induction, conduction by contact, induction, charging without touching. Now, when an object gets this look, where it has positives on one side and negatives on the other, we call this object being polarized. So polarization. How does a negatively charged rod attract a neutral object? So originally I told you a charged object attracts a neutral object. And I told you that's pretty weird, but it has to do with polarization. That's what we're going to talk about now. So what happens is, let's see. So you bring a negatively charged object close to a neutral object. Okay, here, I'm going to use this picture to explain. All right. So what you do is this balloon is negatively charged. So it's overall negative. It's got a few positives in there, but it's got more negatives. So this balloon has a negative charge. What happens, and the wall is neutral. You bring the balloon near the wall, and what happens? The negatives get pushed away in the object. So if we look at the right, the negatives all go to the right and the positive goes to the left. So is this object on the right still neutral? Yes, it has the same amount of positives and negatives. But what happens is now this negative balloon gets attracted to these positives right here. So this balloon will still stick to the wall even though it's neutral. So the idea here is a negatively charged object or a positively charged object can attract to a neutral object only if that neutral object is polarized. What polarized means is positive on one side, negative on the other. If you have an object with positive on one side, negative on another, that charged object will stick to one of the sides. And then that's what polarization means. So a quick review before we get to this lab. A quick review. So we talked about charges, how they attract, repel. We talked about amount of charge. One electron has a specific amount of coulombs. If you need to find total charge, you multiply that by number of electrons. If you have total charge and you need number of electrons, you take total charge divided by that 1.6 times 10 to the negative 19th. So that's amount of charge. And then we have materials, conductor versus insulator. Conductor, electrons move easily. Insulator, electrons do not move easily. We have charging methods, ways to charge objects. Conduction, that's through contact. Induction, that's through no contact. And then we also have this idea of polarization, which is when an object is still neutral, but the positives stack up on one side, the negatives stack up on the other. And then that causes a neutral object to be able to be charged to a different, be able to be attracted to a charged object. And that's it for today.